Hi again. I'd like to continue our discussion of SpriteKit and making a game with SpriteKit. And in the last video, we talked about physics, and what I'd like to do is kind of follow that up and apply it to some objects here on the screen so we can see something happen maybe. To do that, we'll have to make a couple objects first. So far, our game allows us to move this box up and down the screen. Imagine that's our player object. And the player hits the ground. And then these two colored squares here are sort of these background landscape sections that we scroll through, right? So what we're going to do is we're going to make a new type of object and then attach it to one of these landscape sections as it scrolls by, right? And then the player can, pick it up or avoid it, right? So first we need a class to represent that. So what we'll do is we'll start with a coin. Okay, so imagine this is like a power-up of some kind that our player can pick up. So what I'm going to do is create a brand new Swift file, and I'll name it coin, and I'll save it to my folder or my project here. And then I'll import SpriteKit, and then I'll make a new class called coin, and we'll make coin an SK Sprite node subclass. Okay, so that's pretty good so far. Let's initialize the coin like this. And we don't have to say anything here. Coins will always be the same, right? And if we do the initializer there, we got to include the init with coder. So we'll put that in there, just the default thing. And then it's going to say, hey, you don't have super init. So since we're initializing SK Sprite node, we need to make sure that we use the designated initializer, which is initialize with, let me get the one here. With this one, texture, color, and size. Okay. So far, we don't have a texture yet, but if we add a picture, we can include that. So for right now, we'll set that to nil. For color right here, why don't we do UI color yellow color, right? And then it'll just be kind of gold like a coin. And then the size right here will set. So I think what I'll do is I'll just say let coin size equals CG size. And then we'll set the size to, I don't know, how about 20 by 20? Okay, and later we could change this, or maybe we could just use the size of the texture that we use, right? So if we add a coin image or something, we can use that, right? And then we'll put the size down here. So we'll say coin. For some reason I put coint size. Let's fix that. Okay, so there's our object. What am I missing here? What does it say? Sequence action. I don't know. Oh, because somehow I typed sequence action there. Okay, so I'm having keyboard issues today that are all my fault. Okay. Anyway, so we've got that all set up. There we go. Right. Okay, I'm just typing badly. And now what we'd like to do is we'd like to set up our coin, right? So let's use our mark here and just clearly identify the areas of each of our classes, and this is going to be the setup, just like we did in all the other classes. And then this one will say, and we can move that up a little higher, we'll say function setup is going to do something, right? So coins now, let's get back to our physics idea, right? So coins need to have a physics body so we can determine whether they hit a player or not, right? So we're going to set that up here in setup, and then we'll call setup over here from init after super, right? So what we'll do is we'll say PhysicsBody equals SK PhysicsBody, and we'll make a PhysicsBody with a, I don't know, how about a circle of radius, and then our radius can be half of the width, right? So we can say size dot width divided by 2, right? So that'll be the radius. That's not going to change the shape of this, so it's still going to be a rectangle, but the physics body will be a circle. You know, maybe that'll help out later on, right? Circles actually, by the way, are the most efficient shape, I think, to use in the physics engine. So anytime we can make something a circle, we should do it. Okay, so now that we've got that, let's say PhysicsBody.category bitmask equals, and then we'll get physics category, physics category dot, and then we have these categories set up already. So we got player, ground, and none, and coin, right? So we'll choose coin as our physics category. So these objects are category coin, and now they need a collision bit mask and a contact bit mask. So here we make some decisions, right? So the collision bit mask will set to none. Wait, we got to have the uppercase physics category, right? Why none for collision? Because the coins aren't going to show a physical collision with any object. So in other words, like when the player hits them, the player will just kind of pass through, but actually what's going to happen is they'll disappear and the player will collect the coin, right? So we don't want the coin to knock the player or have the player knock the coin around, right? Okay, so we'll just do collision of none, and then we'll say PhysicsBody dot contact test bit mask is physics category player. Okay, so we want the player to contact the coin. Okay, so now we have a problem, right? Because we have to make sure that the player also shows a contact with the coin. So let's go check that and make sure that we have that right. So we'll go back to the player object here. We'll look at setup for player. Hey, isn't it nice the way that we have these all set up the same way? So every time you go to one of these classes for the objects in the scene, they're all going to look the same, right? So their physics body is set up here. Oh, look, we've already done that. So we've got contact test bit mask is coin, right? And then in the coin, it's got contact is player, okay? So that's actually all set up, so we don't have any problems. I thought I hadn't done that yet. So now let's try and create a coin and detect a collision with the coin, okay? So we've got to do two things. First, we've got to create a coin in a landscape and place it somewhere in there. And then when we go into game scene here, we're going to have to use one of the callback for the physics world to detect contacts, okay? So let's do that first because I'm already in game scene. So what we need to do here is the physics engine will send us messages to tell us what's going on, and they do it in the standard iOS system that they use everywhere with a delegate, right? So delegates are used everywhere. Anytime you have a class that wants to send information to some other class, usually you can assign it as a delegate, right? So what we need to do first, though, is we need to declare ourselves as the physics contact delegate. So we'll say physics, what is it? Physics world, no wait, physics, no, SK physics, physics world, or physics contact delegate. There we go. SK physics contact delegate, okay? So an object that implements this protocol can respond to physics bodies, to two physics bodies are in contact with each other, right? So we'll do that, right? And then now what we need to do is we also need to implement the contact delegate callback, right? So what we're going to do is I'm going to find a good spot for that. Why don't we put it here at the bottom, and we'll put a mark in there because this is going to be its own little thing here for physics delegate. So if we had anything else we wanted to do with the physics delegate, we'd put those methods here, right? And then what we're going to type in is we're going to type did begin contact, okay? So did begin contact. So there's did begin contact, and I think there's a did end contact. So did begin means two objects bumped into each other or they made contact. did end means the two objects ended their contact. So this could happen as one object passes through another object. So did begin happens as soon as it makes contact, and then as the object passes through, nothing happens, and then when it breaks out the other side and breaks contact, then it would get a did end contact. Okay, so we're going to use did begin contact, and what we're going to do here is we're going to set up a little situation to like listen for or find out whether we've had contact with another object and which object that is, right? So what we'll do is this. We'll say let collision equal contact dot body A dot category bitmask or contact dot body B dot category bitmask. Now this needs a little bit of explanation here, right? So what's going on here? Well, the did begin contact receives an object from the physics delegate, right? And that's an SK physics contact object. So this object is an object that contains information that describes the contact that just occurred. Okay, so two objects made contact. This is describing that interaction. Okay, this object has two properties, body A and body B, and these are the physics bodies. So you got to remember that the physics body is separate from the sprite that we see on the screen, and instead the physics body represents the physics object in the physics simulation that's somewhere else. We never see it, right? And the only reason our objects move on the screen in relation to the physics objects is because the physics body does something in the simulation, and then it passes its X and Y and rotation and some other stuff to the sprite, and then the sprite sets its position, right? So it's the physics body in the simulation that really is determining like where things are moving in space and the physical kind of interactions that they have, right? So the contact has a body A and a body B, and this is the physics body, right? So if if we mouse over this, right, or option and then click on it, it says SK physics body, right? So one of these could be a coin and one of them could be a player. We don't know which is which. The category bitmask, though, can kind of tell us what category it is, and if we gave the object a name, we could look for the name. If you remember this, our physics categories here are 100 for coins and 001 for the player. So if we take these and we use the bitwise operator OR right here, what we're going to get is something like this. So imagine like this is the player, and this is the coin, and we say this one or that one. Then what's going to happen down here? I'm going to just add another line here. What we're going to get is our collision is going to look like this. Okay, so it's going to be this value, right? It's going to say, hey, there's a 1 here or a 1 here, then we put a 1. If there's a 1 here or a 1 here, we would put a 1, but there isn't a 1 in either of those spots, so we put a 0. There's a 0 here, but there's a 1 here, so either one of these are 1, we put a 1 down here, okay? So if that's the case, this is the value that we're going to get, okay? So that would be what we might see here if body A or body B was the player and the other one was the coin, okay? So that's our collision, right? It might be some other value if these are different things, right? And then what we can do here to check the collision is we can say, hey, if collision equals physics category dot coin or physics category dot player. Okay, so if we get the collision here and it's some value, and then we try and match it to the category, to the OR value for the categories here, then we know that these two match, right? And it doesn't matter which one was A and which one was B. But for right now, what we'll do is we'll say print player actually, let's write it this way. Let's do contact, player, and coin. Okay? We'll put some stars in there just for fun. Okay, and we can continue with this to look at a contact for, player in the ground or player and, some spikes or, other objects in our game. But for right now, we'll just set this up with the coin and the player. Okay, so we've got that. So now we need to actually make a coin that we can run into. Okay, so what we'll do is we'll go to landscape here. And if you recall, actually, let's go back to game scene, right? So we've got this method here that says scroll landscapes. Okay, so this, moves our landscape around. And, every time a landscape moves out of view of the camera, what happens is the landscape gets this message, reset landscape. And what reset landscape is going to do is it's going to change the contents of the landscape sprite, right? So what we want to do is add a coin when this happens, right? And then maybe we want to remove any coins or other objects that are there, right, before we add new ones, right? So let's go over to landscape here, right? And what we're going to do is we have a ground object and then a background sprite. That's the colored box, right? And maybe what we'll do is we'll add one more sprite node in here. Maybe I'll put it after the size there. I'll say let content node equal sk node. And an sk node is like a sprite node, except it doesn't have any picture or color. It's just like an empty sprite, okay? But we can add other sprites as a child of this node. So what we're going to do is we're going to use this as the content. So anything that we add, like coins or spikes or other objects that need to appear in the scene, will be inside this thing, right? And think of it like a layer. Okay, so we're kind of creating a layer that we can add content to, and what'll be nice about this is we can look at this layer and say, remove all the objects from this layer, right? And then we can clear it out and add other objects to it later, okay? So now we're getting an error here because it's going to say like, hey, you use this, but wait, I said SKS node. No wonder, that's a different error. It's going to give me another error saying like, hey, you didn't initialize that, right? So we're going to have to initialize that guy here and then maybe set it up down below. So what we'll do is we've made the ground there. Why don't we say content node equals sk node. Okay, so sk node doesn't really need any parameters there, right? So we'll make one of these sk node guys right here, right? Put it in content node, right? And then what we'll do is down here in reset landscape, what we'll do is where it says other stuff to change, right? We'll do that right now, right? So we'll say content node dot remove all children. So if there's any objects inside or that are child of content node, they will be removed and they're gone. And then maybe we'll add a new item. So let's do this. Let's make a coin and then add it to the content node. So we'll say, let coin equal a coin object, which doesn't require any parameters, right? And then we'll say content node dot add child coin. Okay? So the content node, we didn't set its position, so it should be in the lower left, because if I recall, our background has an anchor point in the lower left, right? So it's down here. So if we were to add this content node right here, actually, what I just remembered, we got to do one more thing. We created the content node, but we need to add it to our scene. So actually, before we get to here in reset landscape, let's go back to setup. And over here, let's do add child content node. Okay, so now content node is part of our scene, and it should be at 0, 0, which would be down here in the lower left. And then in reset landscape, when we clear out the content node, just all of its child objects, which are none right now at the beginning, what we'll do is we'll make a coin, and then we'll clear them all out, and then we'll make a new object, coin, and then we'll add that as a child of content node, and since we didn't set the position of coin, the coin should also be down here in the lower left, right? Which that doesn't work out very well. So let's move the coin out into here. So why don't we do this? We'll just make it random for now. Maybe we'll work on these numbers later, but what we can do is we can say, you know, coin dot position x equals CG float, and then we'll say, you know, arc4 random. They have better random things, but this is random enough, right? And then we'll say mod, and this is a little weird, right? Arc4 random returns an int 32, right? So it's an int 32. So that means if we want to mod it with something, it's got to be an int 32, right? So, or a uint 32. Yeah, I think that's uint 32, right? Yeah, uint 32. So what we got to do is we got to say uint 32. And what I want to do is I want to take the size right here and ask for the width, right? We could make a better function to do this for us, but for right now, we'll just stick with this, and we can add a helper function later, maybe to generate our random numbers. But why don't we do this? Why don't we say size.width, right? So now we've got a random number, but from 0 to 1 less than the width, right? And, you know, it's got to be a uint32 to work with arc4 random here and mod. And then we have to convert this to a CG float, the answer, so we can set the x there, right? Why don't we just copy this line, right? And then we'll paste it here, and then we'll also set the y value, okay? And then we'll set this to the height. Now this is going to be imperfect. We'll have to fix this a little bit because setting the width is okay, but setting the height might put the coin below the ground level, which could be problematic, right? Like if our coin ends up in the ground, so we should have a sort of something less than the height and then add some to move the coin up. But for right now, just for testing, we'll do this, right? Because this video is getting kind of long, and we'll come back and clean this up. But anyway, so there's our coin, right? We've added it to the content node, right? And let's give it a test. We might have to set the z index, but I think since I added this guy afterwards, it should be in front of the ground and the background. So there's our landscape there. Oh, I'm not seeing the coin there. Let's see what could be our problem here. Wait a minute. Let's take a quick check here. So let's try and debug this, right? So so I got this reset landscape. So, you know, either we're creating a coin here and we're not seeing it, or we're not creating coin at all, right? So there's a first premise, right? Why don't we say print coin created, right? And then, you know, we can also just maybe after this we'll print out the coin, right? I don't know, maybe that'll show us some useful information, and we'll give it a test. So we got to wait for one of the landscapes to get off the end, and then that should create a coin down here, right? Oh, coin created. So that looks pretty good, right? Let's take a quick look now. I'm not seeing it, right? So something's wrong, right? So what does it say? It says coin created, and then it says scale is 1, size is 20, anchor point is whatever. Oh, position is 647, 3. Well, that sounds pretty good. That should put it on the screen, right? 3y. Well, maybe that's not high enough. That could be below the ground, right? So that's okay. Let's go look at our coin object. Maybe the coin is created, but we're not seeing it for whatever, you know, reason, right? Oh, you know what? I just thought of something, right? The coin has a PhysicsBody, right? So this guy is what if he had a PhysicsBody and he fell down the screen, right? So it just fell like a you know, physical object, right? And that would happen because the coin is a dynamic body, right? So we can't see it. So imagine that it just appeared just off the edge of the screen and then it fell down and we never saw it, right? You know, what we could do is we could test that if we set the collision bit mask here so that it ran into the ground, right? Then when it hit the ground, it would stop, right? We might have to tell the ground that it also needed to collide with players and coins, right? Okay, so I'll put an OR in there. I'm going to say, hey, you know, your collision bit mask is going to include player and coin category. Let's give that a try and just test that theory out. Okay, so when this blue one gets off the edge, it should create a coin, right? Oh, there's our coin, right? Oh, there's the coin, right? And let's see if it does a collision or a contact. Oh, you know, I didn't see that there. Yeah, I think it landed here and it fell down. But I'm not seeing the contact. We're gonna have to fix that. But anyway, so we found our coin, right? Okay, so let's take this out because we actually don't want to collide with anything, right? So we're gonna take that out of ground. I'll switch to coin. And what we're gonna do with coin on the PhysicsBody is we'll leave all the categories and stuff alone. But what we'll do is we'll say PhysicsBody, and it's got to come after you make the PhysicsBody here, right? And what we're going to do is we're going to say PhysicsBody.dynamic equals false. Okay, so a dynamic body falls down the screen and is affected by gravity and can run into other objects. A static body is fixed; it doesn't move, right? So dynamic bodies are like objects like plates and cups and, you know, things like that, you know, in boxes and things that you can run into. Static bodies are things like the wall or the floor. Now, in our case, the coin isn't really the wall or the floor, but the player is not going to have a collision with it, so it's going to pass right through. So we're going to use this as sort of just like an object that we can contact but don't interact with physically, right? So we'll set this on coin, and then we'll give it another try. I might have to fix that collision delegate, right? Okay, so let's see what happens this time. Oh, so there's our coin was created. Oh, there it is up at the top. Let's see if we can run into it. Oh man, I didn't get a contact. Okay, so let's try that. So let's see what our problem is. So coin has a contact test for player. Player has a contact test for coin, right? So that looks pretty good. That looks good, right? Let's go check our physics delegate, right? So we're going to go back down here to did begin contact, and we're saying like, hey, if the collision includes the coin or the player, I think that should work. Maybe I made a mistake here. Let's check. Well, you know what we can do here is why don't we try and debug it? So what we'll do is we'll put in a print statement here, and we'll just find out, hey, are we getting any contacts at all? Oh, you know, and I just realized what the problem is. But we'll test this because this will actually show what my idea is here that I'm thinking of. I'll put 3 stars there, and I'll say did begin contact. Okay? And then we'll give it another test, right? So this, no matter whether it's player or coin, in this case, you know, any contact should generate a did begin contact. Okay? So let's wait for the coin to show up. It should be any moment now. Anytime here. Maybe that coin ended up underneath the floor there, right? Oh, there's a coin, right? So we can hit that one. And, oh, no contact, right? We did get another coin created, though, so there's another one there, and there's no contact. So we're not getting this did begin contact. So here's our problem, right? In order to get the did begin contact method or message, we need to declare the physics contact delegate at the top to say that we're eligible to be the delegate But actually, we also, to really be the delegate, is we need to assign this class as the physics contact delegate for the physics engine, right? And I forgot to do that. So let's go down. We're in game scene right now. And we're going to go to init, and we see setup here, and this is where we set up our scene. So let's go to setup, and you can see it says, you know, add player, add camera, and maybe at the top here, just at the very beginning of this, we'll say physics world dot contact delegate equals false, no, equals self. Okay, so we're eligible to set ourselves as the contact delegate because we declared that we conform to the physics contact delegate protocol up above right here, right? And so now we can set ourselves as the contact delegate. Now that we've set ourselves as the contact delegate, you know, we'll start getting these messages down here at the bottom. Did begin contact, right? So let's give it a try now. One more test. Okay, so we got to wait for this landscape to go by and generate a coin. Oh, there's a coin right there. And then we'll run into it. Oh, look, did begin contact. So, right, so we got a contact, and it says contact player and coin. Let's see if we can hit this one. Oh, there's another one, contact player and coin. So anyway, so that's working out pretty good. There was some good examples of debugging your code. I hope that's useful to you guys. And thanks for watching.